Hi, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at more chemical reactions. So right up top, we're going to start with some information on double replacement reactions. These they start off by comparing them to single replacement reactions, which are found in the previous chemquest. So remember, a single replacement reaction is when a single atom replaces an ion in another reactant. So if you look down here at question 1, I have a single replacement reaction written, and that's exactly what you see. You have a calcium atom switching places with sodium and sodium chloride. Next, a double replacement reaction. So remember to pause this, write this on your definition sheet. Double replacement reaction is a reaction in which a single ion from two compounds replace each other, and that's exactly what you see here. You have magnesium chloride and sodium fluoride. Again, the positive ions switch places. You'll see that the sodium and the magnesium switch places in the reactants. Again, we look at the second example, same exact thing. Aluminum sulfide and sodium oxide. The aluminum and the sodium switch places in the products. And then the last example, again, you see the same thing. The positive ions switch places. So next, question 1. Question 1 is asking the difference between single replacement and double replacement. So remember, I have a single replacement drawn for you. Remember, single replacement has a single atom in the reactants. Does double replacement have any atoms? Next, question 2. So question 2, you are solving various double replacement reactions. So when you're solving these, remember you need to identify the charges of each ion, and then remember the positive ions are going to trade places. So in this case, the sodium and the copper will be switching places. So on this side of the arrow, it means you're going to have sodium bound to chlorine and copper bound to nitrate. That's what you see over here, copper nitrate. Now we just have to do the sodium chloride. Remember, I did all the work already. Remember, you do have to crisscross. Sodium has a positive one charge, chlorine has a negative one charge, and then we crisscross. Forms sodium chloride. So when you are solving these, remember, figure out the ion, figure out the charges of the ions, then figure out which ones are positive. Those ones will be the ones that switch. Then make sure to crisscross when you combine your new ions. Question 3 is naming two of the products. Remember, use the flowchart that we went over in class, the naming flowchart, ionic or covalent. So now we come to, whoa, uh-oh. Alright guys, so welcome back. Sorry for that technical difficulty. So we are returning on combustion reactions. So a combustion reaction is any hydrocarbon that reacts with oxygen. A hydrocarbon is any carbon that's bound to hydrogen. So right now in pink I am going to highlight the other hydrocarbons that you can see on this page. So the first one is in this reaction. You have C3H8. It's carbon bound to hydrogen, so it's a hydrocarbon. Next, we have 5A, C4H8, hydrocarbon. It's carbon and hydrogen. Next, question 6, you have C6H14. Again, we have another hydrocarbon. It's carbon bound to hydrogen. Next, it does tell us that water and carbon dioxide and energy are always the products. So whenever you have a combustion reaction, those will always be the products, carbon dioxide and water. Carbon dioxide and water. So then in this one, it's easy. It's carbon dioxide and water. The difference is how much water and how much carbon dioxide you have. In the next chemquest, we are going to figure out how to balance reactions. That's where the difference comes in with combustion. So remember, it always reacts with O2, always forms carbon dioxide and water. So question 5, what does it always react with? Remember, it always reacts with O2. Question 6, remember, what does it always form? Always forms carbon dioxide and water. Sorry, this is question 6. That was 5B. Remember what it always reacts with and what it always forms. So now we are moving on to synthesis and decomposition reactions. So synthesis and decomposition reactions, they are opposites of each other. During a synthesis reaction, you have several reactants that combine to make a single product. During decomposition, you have one reactant that decomposes. So I don't like using the same word in the definition, so instead of decomposes, you could put the word splits. So decomposition is when one reaction splits into two or more products. So in this table, you see two examples. So you see that they are opposites of each other. When you have two products, two reactants and one product, then you have a synthesis. When you have one reactant and two products is when you have decomposition. So 7 and 8, that's kind of what this talks about. So remember, synthesis, two reactants forming one product; decomposition, one product forming two reactants. Question 9. Question 9 is taking a look and identifying different reactions that we've looked at. So remember, when you have single replacement, double replacement, combustion, synthesis, and decomposition. So remember, these are the 5 types of reactions that you can have. Remember, single replacement, you have a single atom replacing one reactant, one compound. Double replacement, you have two compounds with ions replacing each other. Combustion is always your hydrocarbon, carbon bound to hydrogen, binding with oxygen. Synthesis is two reactants forming one product, and decomposition is one reactant forming multiple products. So you can identify each of these based on what you know about, based on your definitions for each of these reactions. Question 10 and 11. So question 10 and 11, they're asking you to write two reactions. So remember, it's telling you that it's a combustion, C3H6 hydrocarbon. So remember, what do the hydrocarbons always react with? What do they always form? Remember, decomposition tells us decomposition, calcium oxide. So this is calcium oxide, CaO. Remember, decomposition is the splitting into two products. So what two products could this split into? The next one, we have a couple practice problems. So these are either double replacement or single replacement reactions. Remember, when we work on these, the ions with the same charges switch. So if you have two positive ions, they switch. If you have two negative ions, they switch. And then don't forget to crisscross. Remember to crisscross your products when you have new stuff binding together. And then lastly, question 2 is fill in the blank. You start off by identifying the reaction and then follow the appropriate steps, whether it's single replacement, double replacement, combustion, synthesis, or decomposition, to fill in A, B, and C for question 2 on the practice problems. Like always, circle any questions that you have. Please write down your questions. Make sure you bring them to class. Have a good night, everyone.